The next thing we want to look at is the stages that a rock goes through from the raw blank to the finished point. We've broken it down into 6 stages, and you can see the reduction as the point gets thinner and thinner all the way to the finished point. Here's an edge view showing the sequence of thinning from the initial blank through the stages to the finished point. Okay, this is stage 1. We've just got a raw stone of dacite here. Little test flake has been removed just to sample the stone. Now these stages are arbitrary. They're not hard and fast. Some cultures did things in different ways, but this ordinarily would be stage 2. This is the way most cultures did it and the way we're going to do it. And the first thing is to just take the piece, the raw stone, and to create a working edge all the way around it. It's safe. Some cultures instead would just go right into thinning, like the Paleo cultures, maybe some of the cultures in France, the Solutrean. They would do this overshot technology where they didn't really need to start with an edge all the way around it. They would just start off removing big, massive flakes. It's a little more risky though. Most of this edging work here is done with a hammer stone. I actually prefer that over the bopper, but you might be using a bopper if you're using modern tools. And it's just done by removing short, steep flakes, real similar to making a pebble tool. You're just doing it all the way around the edge. Stage 3 is the initial thinning. The goal here is to try and run the flakes well past the midpoint, preferably close to the opposite edge, or at least 2/3 of the way across. And these are the tools that you would ordinarily use in stage 3. Stage 4 is our final thinning. The goal here is symmetry and to establish the thickness that we're after. Some shaping goes on here, but primarily we're just interested in getting a real nice smooth surface. These are the tools that you'd be using, either a bopper if you're going with modern tools, or I'd probably stick with this size antler at this stage. Stage 5 is shaping. What we're trying to do here is just to remove some short, steep flakes off the edge to get our final shape. Not real short, but we're not trying to remove long thinning flakes along the faces anymore. We're just trying to even it all out. In this case, we're making a lance blade. Here's a close-up of the stage 5 blade. And stage 6 is the finished piece. We finished it with antler or modern tools like copper or nails. Here's a close-up of the last 3 stages. Primary thinning, secondary or final thinning, finish point with pressure flaking on the edges. And these are the opposite faces of the last 3 stages. Now we're going to look at flake terminations. There are 4 that we're considering: feather, hinge, step, and overshot, sometimes called a plunging termination. Feather termination is the one that normally you're after. It shows good control of the napper, has a knife edge all the way around the outside of it, and the nice thing about it is the bottom side, the ventral side, which is in contact with the core, leaves the core nice and smooth and free of defects. That's what you're after. If you have a hinge or a step fracture, the core is going to reflect that, and we'll take a look at that here in a few minutes. But that leaves the surface rough, so you want these nice smooth step terminations. The reason I showed this one here, this is an early stage done with a hammerstone, but you can see how the flake follows the ridge. It's a really good example. We'll get into that in a little bit here. Now this is a hinge termination. It's not the best example, but it's the only one I can find out in my pile. What happens here is that as the flake is peeling away from the core, it starts off with a certain velocity, and that velocity will always reduce. It's sort of a function of length. But if you don't have really good support, the flake speed will drop pretty rapidly, and when it reaches a critical point, instead of continuing on to a feather termination, it'll roll out the backside, and we'll show you what that looks like. Okay, so you can see the flake crack is propagating along like that, and then it comes to the end, and instead of feathering out sharply, it rolled out. This type of a fracture, if it's nice and thin like this, it's not a problem. It's not going to really mess up your core that much. Now in this example, most of the flake is a step termination, but you have a small little hinge right here, and I see that quite a bit as I'm going through the flake pile here. It'll be feather for most of the way around it, and then one small little section will have a hinge. Here's another example of that. Feathers all the way around, except for right here. That's probably the result of these irregularities on the surface of the core. Here's one third example. You can see the flake following this ridge right here. Terminate it with a small little hinge right at this point. And these are step fractures. And these are oftentimes caused by the flake encountering increasing mass as it travels along. Hope that shows up in there. It's kind of a small one, not the best example, but I actually had a little trouble trying to make one of these because I'm not used to ordinarily intentionally making a step fracture. But you can see where it has this characteristic step at the end of it right here. Here's another example. I tried to kind of nap into a little bit of a convexity right in here, which ordinarily you wouldn't want to do in order to generate this one right here. It's very small, but there's a tiny little step right there. Sometimes they're encountered by flaws in the stone will stop the fracture in its path and cause a step fracture. Notice how it's still hung up on there. That's real common, especially if you're napping on your leg. It'll tend to push the flake back down and cause the flake fracture to terminate short of a feather. So you might get something like this, but this is probably caused by a flaw in this stone. Here's another one caused by a flaw, and it stepped in this direction and it stepped in this direction on me, and basically it brought the process to a halt. Kind of a napper's nightmare. This last example is an overshot or plunging termination, and this is the type of reduction that a lot of paleo cultures intentionally utilize in order to rapidly thin their biface. Now I just made this one so the flake broke on me, but in order to demonstrate it, that's what I had to do. So the flake came off over there and came off on the opposite edge, taking part of it with it. And that's basically your overshot flake. Now I'm going to go ahead and attempt to make a second overshot flake right next to the first one here that I just showed you. We've got a nice ridge for it to follow, and I'm sure the paleo folks utilize this same idea here. It requires a really strong platform. What you want is a lot of force to build up behind this, on this platform here, before that crack opens up so that it can push that flake all the way across. The second component is you need really good back edge support, and I used a pretty big moose billet here to pull it off. There's a second overshot. So here's both flakes that we just removed. It's not something that beginners would ordinarily be doing, but I wanted to show you how it's done. So we've got our first overshot flake over here, and then we've got our second one right here. And you can see how that just greatly reduced the thickness of this piece. So in two flakes we've got a lot of the thickness removed, and then a third one could be done right over here. Here's a close-up of the flake. So if you see one of these out in the field on a paleo site or something, what you're looking at is an overshot. Now here's another example of step fractures. This is a thin biface, and when bifaces get real thin, the surface gets real flat, and you're more prone to get step terminations. That's usually what puts an end to trying to get the biface to get even thinner. So this thing here, I've got several, and this is from the pile. Probably something I was working on a couple of years ago. This is also a good example of how step fractures can compound themselves. The first flake was removed here, had a small little step fracture. Moved the second one off over here, and it followed that same step right over here, so we ended up with another step fracture, even worse. And then the last one was right in here, and you can see it's major. And then apparently I tried to get it from this backside over here, so we end up with what's called a stack in the middle right here. Now fingernail step fractures are pretty common with pressure flaking. I'm going to try and make a couple right in here. Here's a small remnant of a step fracture from that pressure flaking I just did. Here's another example. We'll continue this in the next segment.